Hello everyone, welcome to my channel. Today we have a very special topic in LPP, linear programming problem, that is the chapter of assignment problems. How to solve assignment problems and what are assignment problems. So assignment problems are basically particular type of transportation problem. You have seen that in transportation problems end origins and end destinations are there are some demands, there are some availabilities, so that type of. But here you have end origins are to be assigned to an equal number of destinations in one to one basis. So let's see. Yeah, assignment problem is a particular type of transportation problem that I was talking about, where end origins are to be assigned to an equal number of destinations. So you have a square matrix in this case, in most of the cases, in one to one basis, such that the assignment cost is minimum, or if it is a profit matrix, it should be a maximum. So that is your assignment problem. Okay, let's see what is the formulation of the assignment problem. Let's have an example. In a factory there are n jobs, a1 a2 an, and there are n workers, b1 b2 bn, and Cij is the assignment cost of the ith job is assigned to jth man. That means b1, the man b1 is assigned to a1, so the cost will be c11. So c11 is the assignment cost of the b1 job a1 is assigned to b1. Similarly, we can explain c12 is the cost assigned for the job a2. If this is your job, if these are the, suppose these are the computers and these are the persons, right? b1 b2 bn are the persons. You can say faculties, you can say IT fellows, all this. So this b1 is assigned to a1, b1 can be assigned to a2, b1 can be assigned to an. These are jobs. So what is the cost of assignment? So c11 is the cost of assignment if b1 is assigned to a1. If b1 is assigned to a2, then c12 is the cost. If b1 is assigned to an, c1n is the cost. Similarly, you will go for the person b2 or the man b2. If assigned to a1, then the cost will be c21. And if b2 is assigned to a2, the cost will be c22, and so on. So this is your cost matrix. Okay everybody. So you have to find out by the problem assignment cost. The cost will be minimum, you have to minimize. And if this is a profit matrix for a company, then the company has to maximize the profit. Okay, so that is the difference. So now let us formulate the assignment problem. That may be the question for you. What is the mathematical formulation of an assignment problem? Let xij be a variable defined by, if xij equal to 1, if ith origin is assigned to jth destination. Okay, so if ith origin is assigned to jth destination, xij will be 1, and xij equal to 0 if ith origin is not assigned to jth destination. So xij is a variable and it is defined in this manner. So in LPP you have seen that the problems can take any real values. Positive, must be positive. But in this case, you see the variable can take only 1 and 0. So now the assignment will be optimize z equal to. So xij is the variable assigned to ith to jth destination, ith origin to jth destination, or ith fellow to jth job. So the total cost will be Cij xij. Okay, so you have to optimize this. Z equal to summation I equal to 1 to n, summation j equal to 1 to n, Cij xij, subject to summation j equal to 1 to n, summation I equal to 1 to n, xij equal to ai equal to 1. Okay, I equal to 1 to n. and xij summation I equal to 1 to n summation j equal to 1 to n xij bj equal to 1. Actually, this is your ai. This is your ai, right? ai, and this is your bj. So this, you know, for a balanced transportation problem, this should be equal, and assignment problem is a particular type of transportation, so that is the restriction here. xij, this is 1 and this is your 1, and this is the balanced thing, that summation j equal to 1 to n ai and summation I equal to 1 to n, this should be that bj equal to n. So summation I equal to 1 to n, this is I actually, this is your I. So this is the mathematical formulation. Okay. Now let us come to the important part of our topic, that is the main target is to solve an assignment problem. How will you solve an assignment problem? So yeah, I'm giving you the idea by Hungarian method. Actually, the method itself is called the Hungarian method, and I will discuss the method step by step. So that method is Hungarian method. So let us start with an example, and I will give you the steps in the problem solving. Find out the optimal assignment cost from the following cost matrix. So you have a cost matrix, right? You see, you can find the cost matrix, and the jobs are 1. Suppose the jobs are at the top 1, 2, 3. Okay, these are the jobs, and 4. There are 4 jobs available, and there are 4% A, B, C, and D. Okay, there are 4% and there are 4 jobs available. So, and their costs are given inside the matrix. This is a cost matrix, assignment cost matrix. Okay. Now this is a problem of minimization. Okay. If this is a cost matrix, this is a costing will be minimum. So this is a problem of minimization. How to solve? Step 1. Subtract the lowest element 5 of the first row from all the elements of the first row. So look at that. You consider the first row. You consider the first row. What is the minimum element in the first row? 5. Right? Minimum cost is 5. Minimum element is 5. So you subtract 5 from each element of the row. Right? So all the elements of the first row. So what you have, if you subtract 5 from 9, it will be 4. 6 minus 5, 1. 6 minus 5, 1. And 5 minus 5, 0. So look at that. You have 4, 1, 1, 0. Clear? Similarly, you go to the second row. What is the minimum element in the second row? 6, right? You subtract 6 from each of the elements of the second row. So 8 minus 6, 2. 7 minus, oh, sorry. I got a, it's not, it's 5. Again, 5 is the minimum element, not 6. You can verify that. So if you have done any mistake, any error, you can easily recheck that one. So 5 is the minimum element. So 8 minus 5, 3. 7 minus 5, 2. 5 minus 5, 0. And 6 minus 5, 1. So you can check. This is the second row. Similarly, go to the third row. What is the minimum? Again, 5 is the minimum. So 8 minus 5, 3. 6 minus 5, 1. 0 and 2. 3, 1, 0, 2. Okay, this is the third row. First, second, third. And we'll go to the last one. 8 is the minimum element in the last row. That is the fourth row. So 1, 1, 0, 0 is the corresponding matrix. So this is your step 1. That is, you have to subtract the lowest element from each element of that row, particular row. Okay. Next is step 2. After this is your table 1. After this operation, this is 1, table 1. Okay. You can mark them by this. You can write these steps. So go to the table 2. Subtract the lowest element of each column from all the elements of the corresponding column to get the matrix. So you do the same process, but you will do in the column. So you see in the first column, you have 1 is the minimum element, right? In the first column. So you subtract 1. So you have 3, 2, 2, 0, right? 3, 2, 2, 0. You go to the next column. 1 is the minimum element, right? You do the same process as you applied in row. So 0, 1, 0, 0. So it is 0, 1, 0, 0, right? You go to the next. 0 is the minimum, so it remains unchanged. Yeah. If 0 is there, then it remains unchanged, because okay. So the third column remained unchanged. You go to the next one, 0 is there, so it remained unchanged. So next two rows, columns remain unchanged. So this is the so what you have done, subtract the lowest element of each column. That is the same process you have applied in the rows, from all the elements of the corresponding column to get the matrix. Okay, so this is your table 2. Next, now you have to connect all the zeros of matrix by a minimum number of horizontal and vertical lines, dotted lines. So I will connect all the zeros of the matrix by a minimum number of. That means you have to draw minimum number of lines connecting maximum number of zeros. So this word is very, very important, minimum. So by a minimum number of horizontal and vertical lines, it can be horizontal lines, it could be vertical lines, but you have to draw minimum number of lines. So let me, yeah. So I'm connecting this one. This is your first row, because you see maximum number of zeros are covered. 4 zeros are there. So this is your horizontal line. Now you can take, yeah, you can take another, yeah, this covered 2 zeros. Again the first, yeah, this covered 2 zeros, and the last one you can draw column, vertical or horizontal. So you can see all the zeros are covered. All the zeros are covered. Let me show you once again. So you have to draw minimum number of horizontal and vertical lines. Okay, dotted lines, you can put dotted lines or straight lines. Okay, so minimum number of horizontal and vertical lines to cover the zeros. So look at that, fourth row contains maximum number of zeros, 4 zeros. So I will cover them by a line. Yeah, this line is, these zeros are covered. So this is horizontal. You can draw vertical also. So if I draw this vertical line, it will cover 2 zeros, and if I draw another vertical, it will cover 2 zeros, and this 1 0 is left. You can draw vertical or you can draw horizontal. So I'm taking vertical, you can draw horizontal. So how many lines are there? Number of lines is 4. What is the order of the matrix? 4. So this is the condition of optimality. Number of lines equal to the number of dotted lines. If the number of lines equal to the order of the matrix, the optimality conditions are satisfied. So that is the only optimality conditions. If the number of lines equal to the order of the matrix is 4 cross 4, 4. It's a square matrix. So order of the matrix is equal to 4 and the number of lines is equal to 4, then the optimality conditions are satisfied. Okay, clear everybody? Now go to the okay, now go to the, yeah, the fourth step. Write all zeros in a transportation table. So you write all the zeros here. You write all the zeros. You have all the zeros here. Yeah, the wherever they have the places, you put them. 4 zeros at the last row. You see 4 zeros at the last row. Okay. Yeah, I have to put that. Okay, 4 zeros at the, and you have 2 zeros, 2 zeros at the second row, 1 0 in the third row. From the bottom I'm calculating. So you see all the positions are there. 2 zeros, 1 zeros, and in the first row, you have this 0 here, this 0 0 0. So yeah, okay, these are the zeros. Okay, now respective position and cross of the zeros at the points of intersection of the lines. Okay, you do not consider the zeros at the intersection. You don't have to consider the zeros at the intersection. So you see, I have an intersection point here I have an intersection point here, and I have an intersection point here, and I have an intersection point here. So I will not consider these zeros. Let me show you once again the table. This is the table, okay? And okay, let me draw the rows. That will be clear for all of you, okay? And you see 0 0, okay, 0 0. I'm considering 0 0 and 0 0, right? And the last 0, okay? Because I'm not considering these two zeros with blue encircle, because these are the intersection. That means two lines, horizontal and vertical lines, intersect at those positions. So I am not considering this. Only consider those are not at the intersection. So I'm considering those are not at the intersection according to your diagram. Maybe someone put horizontal zeros instead of vertical, so they have a different intersection. You could have different intersection, but you have to consider all the zeros not at all at the intersection points. Okay, everybody? So now what is your target? Now you have to select the zeros. Each row and column contains one zero. You have to select the zeros in such a way that you have select 4 zeros in such a way that there is only 1 0 at each row and each column. Listen carefully. Select 4 zeros because you have 4 matrix, so you have to select fourth order matrix. 4 zeros in such a way that each row and column, each column contains only 1 0. So now select the first column. So I'm selecting this first column. So you have 1 0 only. In the rows and column intersection, you see if you have zeros here, you have to cross off them. Okay. Next, select second row. You see there are only 1 0. So you select this 0 and cross off the other zeros. Okay, everybody? And you see in the second row, you have 1 0. Right? You select this 0 and cross off other zeros. And lastly, you have only 1 0 that is in the first row. So you see in the row and column intersection, first row and the last column, there is only 1 0. Second row and that column intersection, second column, you have only 1 0. Third row and second column, you have only 1 0. And first column and fourth row, you have only 1 0. This way. So you have to select zeros in such a way each row and each column contains only 1 0 and cross off the other zeros. Okay, everybody? I'm giving you again. I'm showing you again. Yeah. So these zeros will be okay. These are the intersection. So this 0 won't be there, right? Okay, this 0 won't be there because this is the intersection. Look at that. Yeah, this is the intersection. So 3 zeros are not there. You have only this. Okay, I'm showing you the method once again. So you have to select zeros in such a way that there is only 1 0 in each row and each column. Select the first column. Okay, first column, and you have a single 0 at 4,1 position. This is your 4,1 position. Select this 0 and you have no zeros already cross off. Okay, next now select the single 0 at cell 3,2. Single 0 at cell 3,2. So 3,2, you select this one. Third row, you select this one, or you can select this one, or you can select, sorry, you can select this one, 2 3 position. So this row have only 1 0, so you cross off these zeros. Okay, you cross off these zeros. Okay, next select this 0, then cross off this 0, and this is the remaining zeros. So you see you have a diagonal. Okay, only 1 0 in each row. This is the main important point. So this is your 1, this is your 2, this is your 3, this is your 4, right? And this is your A, B, C, D. Suppose. So 1 is assigned to D, right? And 2 is assigned to, suppose 2 is assigned to C, and 3 is assigned to B, right? And fourth is assigned to A. Okay, everybody? Fourth is assigned to A. So this is the assignment. Okay, maybe I have inverted ABCD here and 1 2 3 4, but the thing is this. Okay, so here the explanation is there. Select 4 zeros. This is the most important part of assignment problem. 4 zeros in such a way that there is only 1 zero in each row and each column. Select the first column containing only single zero at cell 41 and then cross off all the zeros of the fourth row, and similarly you do the process. Now this is hence the optimal assignment is unique, and the assignment is D to 1 or 1 to D. I have inverted the ABCD and 1 2 3 4. And the assignment cost is, what is the cost? You go to the original matrix. You go to the original matrix. Yeah, these are the assignment costs. So D is 1. So you have to take 9. You have to take 6. This is diagonal. 5 and 5. So you add them, you will get the assignment cost. Okay, everybody? So this is your assignment cost, you see. So this is very simple, but the main important part is selecting the zeros and draw the lines. So let's come to another problem. 9874, you have an optimal assignment cost matrix. So you have 98764, 57568, and this is the cost matrix given. So let's apply the assignment problem, Hungarian method here. So you see the minimum element here is 4, right? And minimum element here is 5, and minimum element here is 3, and minimum element here is 3, and minimum element here is 5, right? So 4 5 3 3 3 3 5. So you go to the matrix and write, apply your method, row and column. Okay, you can apply column also, column operations also. After that you will get the final. I will write the final. I have the solution with me, so let me write the final thing here. Okay, after the operations, okay. So after the operations I have 5 row and column operations, right? 5 2 3 2 0 and 0 0 0 1 3. You will have, you can check that 5 2 3 0 2 5 0 1 6 0 and 1 0 1 3 0. This is the matrix after applying row and column operations. Okay, now you have to draw the dotted lines, horizontal and vertical, minimum number. So you see second row contains 3 zeros. So let me mark with dotted line. Yeah, and you have this last column having maximum number of zeros, that is 3 zeros, and you have this column having maximum number of zeros, and you have this row, so you, yeah, zeros, all the zeros are covered. You see all the zeros are covered, there is no zero uncovered. Now you see the order of the matrix is 5 and the number of lines is 4, that is not equal to 4. So order of the matrix is not equal to the number of dotted lines. So optimality condition is not satisfied. In this case, what you have to do, you have to select, optimality condition is not satisfied in this case. So this is very, very important. You have to select the smallest element after 0. So smallest element is 1. So subtract the smallest element from all the elements of the remaining rows and columns which are not covered by the lines, and add the smallest element to all the elements which lined on the points of intersection. Let me line this one. Okay, let me add this one here. Subtract this rule. Actually, I'm writing the rule. Subtract the next smallest element after 0, that is 1, from the elements of the remaining rows and columns which are the following table, which are not covered by the lines, and add that smallest element to all the elements which lie on the points of intersection. Okay, so this is the case when the optimality condition is not satisfied. Points of intersection of the lines, to get the matrix. Okay, everybody. So you have to subtract. The main important line is you have to subtract the smallest element 1 from all the elements of the remaining which are not covered, and you have to add the smallest element to the points of intersection. So what are the points of intersection here? This is the point of intersection 1, this is the point of intersection 3, this is the point of intersection 2, this is the point of intersection 2, right? So you have to add 1 here, so it will be 1, 3 plus 1 4, 2 plus 1 3, 2 plus 1 3, so you have, and 5 minus 1 4, this will be 4. If you subtract, this will be 3 minus 1 2, this will be 1, right? And these are covered elements are remain unchanged. This 5 will be 4, 1 will be, you are subtracting, right? 1 will be 0, and this 1 will be 0, this 1 will be 0, this 6 will be 5, and this 3 will be 2, and you write the matrix once again. Okay, let me show you once again. Let me write that matrix. So you have 4 2 2 1 0, and you have 0 1 0 1 0, 5 3 3 0 3, and you have 4 0 0 5 0, and you have 0 0 0 2 0. Okay, everybody, so this is the final matrix after this operation. So this is the most important thing. If the optimality condition is not satisfied, if the optimality condition is not satisfied, okay, is not satisfied. Okay, I'm not writing that thing, is not satisfied. Okay, so optimality condition is not satisfied. This is the operation, this is the main operation of assignment problem, and you have the similar table. So again, cover the zeros. So you have maximum number of zeros here. Okay, you have maximum number of zeros, 3 zeros, so drawing, and you have 3 zeros. Okay, but these 2 zeros are left. You have to draw horizontal or vertical. So let's draw a vertical line. This is horizontal line, so this 0 is covered actually. Okay, Okay, let me cover the zero. Yeah. Oh, sorry. Okay, so all the zeros are covered. So how many lines? 5. And order of the matrix 5. So optimality condition is satisfied. Okay, now you have to select the zeros once again, just the similar process. Okay, so let me select the zeros, but don't take the intersection zeros. So these are the intersection zeros at the intersection, don't consider them. So I'm not considering this, but I will take these zeros. Okay, let me draw the table now. 5 cross 5, so I have to draw 1 2 3 4 5. 1 2 3 1 2 3. I have to draw another one. 4 5 1. Yeah, 5 rows, 5 columns. So take the zeros. You have here, you have 0 0 3. So in the first, okay, in the second and third, okay, and you have a 0 here, okay, and you have a 0 0, okay, and you have a 3 zeros in the last row. Okay, so these are the zeros. I'm not considering the intersection zeros. Okay, zeros are which are at the intersection. I'm not considering that. Now you have to select the zeros and cross off the other zeros. So you see in the first row you have only 1 0. Let me select this one and cross off. There is nothing, because in this row and column you have only 1 0. In the first row and the first column you have only 1 0. Next, consider, yeah, this one. It's better to consider this one. So you see in the third row and third column you have only 1 0. Okay, now you can consider this 0. Okay, you can consider this 0. Okay, let me consider this 0. If you consider this 0, then this 0 cross off, these zeros cross off. You can arbitrarily select sometimes in this case. So next you go to the fourth row, you have only 1 0. So you consider this 0, this row 0 will be cross off, and another 0 left in the last row. So you have, this is the assignment. You can select these zeros also. You can trial and error method. So there may be multiple solution exist. So this is the case. So if this is the matrix, this is suppose 1, this is suppose 2, this is 3, percent 3, this is suppose percent 4, and this is 5, and this is your A, B, C, D, and E, right? So you can have your assignment is 1 to E, 1 goes to E, right? 2 goes to B, C, right? 3 goes to D, okay, and 4 goes to B, right, and 5 goes to A. 5 goes to A. So this is your optimal assignment, and the optimal assignment cost will be given by the from the main matrix. That is, you can consider these elements and add them, you will get the answer. Or this is not unique. Actually, you see in this problem, this selection is not unique, because I have selected this. You can select this also. You can select this also. So in that case, you have to cross off these zeros. You have to cross off these zeros. So this assignment is not unique. Okay, my dear students, this assignment is not unique. So you in assignment problem, you might have optimal multiple assignments. Okay, so this is the problem of assignment problems. I hope this is clear to everybody. And I want to tell you one more problem. Not I will. I'm just telling you, if this is a profit matrix, you have to minimize. You have to subtract. You have to clear. Do the minimum optimal assignment, select the lowest element from, in that case, profit matrix. Then in that case you have to select the minimum, and you have to subtract from all the elements in case of profit assignment matrix. So I hope this problem of assignment problems is clear to you, and how to solve the problems, how to deal with the problems, how to go with the problems. Okay, so follow my channel and subscribe my channel and see my videos. Thank you all of you.